Hey everyone! Welcome back to our channel. If you're passionate about data science, machine learning, or just curious about how we can make better predictions with our models, you've clicked on the right video. Today, we're diving into an essential concept in the world of machine learning, L1 and L2 regularization. So, let's get started. Before we jump into the details, let me ask you this. Have you ever built a model that performed exceptionally well on your training data but completely flopped when faced with new data? If so, you've encountered a common problem known as overfitting. And that's exactly where L1 and L2 regularization come into play. So, what exactly are L1 and L2 regularization? In simple terms, both are techniques used to prevent overfitting by adding a penalty to the loss function we use to train our models. This penalty discourages the model from becoming too complex by reducing the influence of less important features. Let's break them down one by one. First up, we have L1 regularization, also known as lasso regularization. The main idea behind L1 regularization is to add the absolute value of the coefficients to the loss function. This can be mathematically represented as loss underscore L1 equals loss underscore original plus lambda sum W underscore I, where lambda is the regularization parameter and W underscore I are the coefficients of the model. A unique property of L1 regularization is that it can shrink some coefficients to zero. This means it effectively selects features, keeping only the most important ones. For example, if you're working with a dataset that has hundreds of features, L1 regularization can help you identify the few that really matter, simplifying your model and improving its performance on unseen data. Now let's talk about L2 regularization, also known as ridge regularization. In contrast to L1, L2 regularization adds the square of the coefficients to the loss function. Loss underscore L2 equals loss underscore original plus lambda sum W underscore I caret 2. Unlike L1, L2 regularization doesn't set coefficients to zero. Instead, it shrinks all coefficients towards zero but keeps them non-zero. This means L2 is more about keeping all features while controlling their impact on the model. It helps in situations where you believe all features have some degree of relevance but may need some restraint to prevent overfitting. To illustrate this with a practical example, let's say you're building a model to predict housing prices based on various features like square footage, number of bedrooms, age of the house, and so on. If you apply L1 regularization, you might find that the feature age of the house gets its coefficient set to zero because it doesn't add significant value to your predictions. In contrast, if you apply L2 regularization, you may see all features still included, but with smaller coefficients indicating they all contribute, albeit slightly. It's also worth mentioning that choosing between L1 and L2 regularization often depends on the specific context of your problem. For instance, if you suspect many features are irrelevant and want a more interpretable model, L1 might be the better choice. If you believe all features have some relevance and want to avoid the risk of losing potentially useful information, L2 could be a better fit. Lastly, there's a third option called elastic net, which combines both L1 and L2 regularization. This can be particularly useful when you're dealing with datasets that have highly correlated features. To wrap it all up, L1 and L2 regularization are powerful techniques in the toolbox of machine learning practitioners. They help us create more robust models by preventing overfitting and improving generalization on unseen data. If you found this video helpful, please give it a thumbs up, subscribe for more content like this, and share with your fellow data enthusiasts. And don't forget to hit that notification bell so you don't miss our next video. Thanks for watching, and happy modeling!